All right. Okay. It has started recording. Let me share my screen. Mm, okay. Um, right. So I'm going to start with the practicing the nomenclature of the compounds and acids. Yes, there is no other way to remember those things without memorizing the names. I'm so sorry. That's the least favorite thing for myself to ask students to memorize or something when it comes to memorize. Yes, but please um, put a list. I think I have posted a list of the names that you should practice on the blackboard under this module 4. If you can get a printout of that and just keep in a place where you see it, or you can put it on your desk, that would let you memorize. You get familiar with those names. You will make yourself get familiar with those names. That would be another method that you can start. You can make or give yourself an like a comfortable way to memorize these things. Do not try to exhaust yourself. Don't stress yourself out. Then you would find it difficult to remember these names. But there would be like um, three to at least three questions based on the nomenclature on the exam. Let me be clear on that. Three questions on the like asking you to name, or you will be given a formula and try to and asked to name it, or you'll be given the name and you have to build up the formula. So there will be only three to uh, four questions, only three to four questions. That's all. Right. Okay. So, and and you will be given the periodic table. So then you know the in the periodic table you will see the name of those elements. So that would be also helpful for everybody to find a method way to start naming these compounds. So when you look at the periodic table, you will figure out the S for the sulfur, and this is the oxygen. So we'll name that one, write it, write the name, sulfur, or you can also name it as SAUL as sulfur. And now we have three oxygens here. So we don't put the oxidation number in the parentheses, but you should tell it as sulfur trioxide. Then sulfur trioxide. Okay. So this is sodium. So you can look at the periodic table, you will see that it is the sodium. Sodium is in period the column number 1. So they'll make only just one type of ions, that's +1. When you look at the cyanide, it's a multi-atom anion. So that will be SCN. The charge of the cyanide is minus. So now we'll write those two together. Okay. So +1 and -1. So there will be cancelling out, and the chemical formula for sodium cyanide is NaCN.
When we, okay, here is a good example. Now we have iron chloride. Okay. Mm, right. So iron is in a transition metal ion. So iron can make plus 2 ions or iron plus 3 ions. So in this example, we should clearly mention what is the uh, oxidation number of the ion. So it will, in order to find the oxidation number of the ion, should be started with the chloride ions. One chloride is minus one. So we have three of those. So, and there is nothing on the iron. So that means iron had something that was able to completely neutralize the uh, charge brought by this the chlorides. So it's minus one should be cancel out by the cancel out by the positive threes. So that in that case we can mention the charge or the oxidation, actually the oxidation number of the ion as 3. Oh, mm, and here we'll write the, oh, what's going on, the as the chloride. You don't need to mention the oxidation number of the chloride because it always makes this the minus one. Right. You have any questions so far? Right. The next one is an acid. So the name of this one is the hydrochloric acid. Right. Next one, nitrogen trichloride. The name itself tell you what you should use. One nitrogen and trichloride. We have three chlorines. So the formula should be NCl3 subscripted. So in some equations, the chemical formulas may give you the three which not subscripted. Or if something given like this. So that's completely wrong, right? So this is wrong. The three should be subscripted, not superscript. Right. Next one, aluminum carbonate. Again, here is the aluminum, but carbonate is a multi-atom anion. What is the charge of aluminum? Aluminum does not make more than one charge. So it's in the column number 3. It's a metal ion. So it makes plus 3, releasing the 3 electrons in that valence shell, S2P1. The carbonate, it is a multi-anion, so it has CO3 2 minus. So now we should write these two. So I'll write that aluminum and carbonate. Right. But now these one brings plus 3, the other one brings 2 minus. They are not canceling each other. So I just crisscross these things. I bring the 2 towards the aluminum and I bring the 3 towards the carbonate. When you put the 3 in out on the carbonate, make sure you put these two brackets. Next one, both of those are multi-atom ions. This is ammonium, and the other one is sulfate. Right. So ammonium makes the plus 1 ions. Sulfate makes the -2. Right. So that's why we have subscripted 2 over the at the ammonium ions to neutralize, to balance the charge that brought that was brought by these sulfate ions. So the name is ammonium sulfate. All right. Nitric acid. Always the acids should have a hydrogen. Acid is a substance that should be able to donate H plus, release H plus. So acids should have that one or two, one or more hydrogens. Nitric, NO3, HNO3. Questions. Next, magnesium hydroxide. Again, magnesium is in the column number 2. That makes only one type of charge, that is plus 2, because it's the valence shell electron configuration is S2. Those 2 electrons will be lost, will be removed, and will make these plus 2 cations. Hydroxide is a multi-atom anion, and that is OH minus. Okay, so this is, we can now balance it out because the magnesium brings plus 2, hydroxide bring just 1 minus. So we should balance it, putting the subscripted 2 there. Right. Next, the calcium. Calcium, we don't need to mention its oxidation number because that makes only one type of ion. So you can just write the calcium. And the chloride. Chlorine is also making just one type of the ion. So you can simply say it is calcium chloride. Right. Next one, the boron. Boron has 3 Fs, but fluoride. So in this case, we cannot, this is not an ion, the salt or ionic compound. So this is a covalent compound. So we have to mention the what, how many fluorides are there. So we should name this as boron trifluoride. Yeah, you would wonder what is the difference. Yes, because in that case we have a covalent bond. That is the reason. The next one, calcium carbonate, it's again a salt. So the calcium is just Ca. It makes only 2 plus ions. Carbonate is a multi-atom anion. It is CO 3 2 minus, right? So this 2 minus to 2 pluses are cancelled, will be cancelled out. So we can write CaCO3 as the chemical formula for calcium carbonate. Next one, what is this? Yes, you'll know that, right? It has a hydrogen on it. So this must be an acid. Yes, the name is sulfuric acid. Right. Okay. Here, the name sounds itself like giving you all the hint of this, the formula. Diboron. When it says diboron, we should put the subscripted 2. Tetrahydride. Hydride is here and tetra means 4. That is the formula for the diboron tetrahydride. Um, okay. Do you have any questions? Right. Next one, the nitrogen and oxygen. Nitrogen makes like the several types of oxides. So this one is the nitric oxide. The In nitric oxide, what is the oxidation number of the nitrogen? Because oxygen always makes that the 2 minus the oxide ions. So the nitrogen in this case, it is plus 2, right? Nitrous oxide is here. Nitrogen, dinitrogen pentoxide is over here. Yeah, and like that. Nitrogen makes several types of oxides. So I just wanted to give you explain the other types of the nitrogen oxides. Next one, chromium chlorate. Okay, chromium is this. The chromium is a transition metal ion. Metal. Since it's a transition metal, it can make different types of um, the ions. So now we must know the charge of the chlorate. ClO3 minus. Okay. So uh, the chlorate ion. Okay. Chromium chlorate. The Hold on. Right. So we must know what is the charge of the chlorate ions. Okay. So this the chlorate is just only the um, hmm, what I must say here, actually the name sounds wrong to me. Right. Why? It didn't tell us the exact oxidation number. So this name is wrong itself. Okay. So what I would say, this is a wrong name. So if, as an example, let me tell you the correct name. Correct name is chromium. That's my bad. 3 chloride. Okay. Now it makes you a doable question, right? Okay, now it's chromium 3. So we know it is plus 3 and ClO3 minus, right? So now we can just balance that, put in the 3 over there, right? So you understand, whenever you are given or when you see a transition metal in the name, please make sure you put that the oxidation number there, because the transition metals make more than one charge. Like iron make plus 2 and plus 3. Here the iron plus 2 and plus 3, like that. Chromium can make the 3 plus or 6 plus, and manganese can make the plus 2. Here manganese can make plus 2 or plus 5 or plus 7, right? Like the different types of ions. So when you are naming a compound with the um, transition metal, make sure you mention the oxidation number. But anything else, like in a S block, you don't need to write the uh, oxidation number, because they make only one type of ion. That's it. Group 1 makes all the ions with plus 1. Group 2 makes the plus 2. That's all. Right. You have any questions? Right. I think I'm just going to stop sharing my screen now. Right. Okay. This is now I'm going to stop the uh, recording. Yeah. And